In this video, I'm going to go over a few of the basic variable types in Python, as well as a couple of functions that just help us to see what's going on behind the scenes when we do this. There are definitely more variable types than what I'm presenting here, but I want to start off with the basic, most commonly used ones. So I'm going to start with integer, and an integer is any sort of whole number, can be positive, negative, zero, any sort of whole number that doesn't have decimal place. So, it could be something like 10, but an integer wouldn't be like 10.35 or something. So whole numbers only. Of course, I can just type them and we'll have that value, but more often than not, we want to store our values into variables. So I might have something like x equals 10, y equals 5, and these are going to store integers into the variables x and y. So if we want to know the type of the information in our variable, we can use the type function. So I could say type x, and you can see here it's telling me that it's class int, but this just means it's an int, which is short for integer. I could also do type, and I don't have to put a variable in there. I could do -9, and this will still tell me that -9 is of type int. If I have something after the decimal place, like 10.35, as I mentioned earlier, that's not an int, it's a float. So if I do type 10.35, you'll see that it says class float, and float is referring to any numerical value that has a decimal. And we can use these as you would expect with our math operations. So I could do something like float value equals 10.35, and then I can use this to do any sort of math operations. So I could do something like float value plus x, and it's going to add up x, which is 10, and float value, which is 10.35. Something to note, but I'm not going to talk about too formally right now. I called my variable float value because I didn't want to just call it float, because you never want to use a word that already has a meaning in Python. It can sometimes mess it up. So I just called it float value instead of just calling it float, just so that there's no ambiguity when the interpreter is trying to figure out what to do. And if I clear this, I still have, the variables are still going to be stored until I terminate my Python session, or until you terminate your program, or it goes out of scope. So here I could do something like print x, and x still stores the value 10. So the print function is just a way to have us print whatever sort of data that we want so that we can then view it. So I can do print x. I could even do something like print x to the y power, and you can still do a mathematical operation here. The parentheses will be evaluated first, and then the result of this will be printed. To further elucidate that point, I could do print 5 plus 4 divided by 2, and we get 7.0. Something to note here with the variable types, this is a float, the output here, 7.0, even though I did 5 plus 4 divided by 2. The reason for that is that if I do division, so 5 divided by 3, for example, 5 and 3 are both integer types, but when I do division, we often end up needing a float type, because a lot of the times, unless it goes in evenly, we're going to get a decimal. So 5 divided by 3 is 1.6 repeating. So division will take two integer types and it'll convert the result to a float type. So here, what happened was, even though I used all integer types in here, when 4 divided by 2 was executed, it did 4 divided by 2, and it read that as 2.0 as a float type. So division will result in a float, even if it goes in the correct number of times. So this would have become a float type, and we still would have been adding it to an integer, but if you're adding an integer and a float, the float takes precedent, and you end up with a float type. And that's because if I do 5 plus 4.1, for example, the result of this addition is going to have a decimal. So the float type will always take precedent if we have, if we have integer and float mixed when we're doing addition or subtraction. If I do type of 5, you can see this is int. If I do type of 4.1, you can see it's a float. And then if I do type of 5 plus 4.1, you can see that it's a float. So even though one's an int and one's a float, the result will be a float. If I do 8 divided by 4 and I look at the type of this, you can see it's a float. So 8 divided by 4 is 2. We know that 2 is an integer, but the division will convert it to a float type. We can also see that if I just do 8 divided by 4, because it gives us the result, but it gives us the result as 2.0. And once we see that there's something after the decimal place, we know it's a float type and not an integer type. So an integer type will just, be like 2 or 8 or something and have no decimal. We can convert a float to an integer if we want. So maybe I want the result of 8 divided by 4 to be given to me as an integer type. And the way I do that is I just use the word int and I put the value that I want to make into an integer in parentheses. So I could also do int of 2.000, which is going to be a float type. But if I put int around it, it just changes it into an integer. You can see there is no decimal here. The other thing to note that this int function does is also if you give it a float that does have something after the decimal, if it's not just like 2.0, something like 1.33, you can see it just drops the decimal place. It's not rounding, it's just dropping whatever's after the decimal. So if I did int of even something like 9.9999999, which is really close to 10, if I have this integer wrapper, if I convert the type to integer, it's going to just chop off the decimal and make it into 9. This can be useful because sometimes we want to guarantee that something's an integer. So maybe we want to figure out how many participants were in a race or something, and somehow because of rounding errors, the result ends up being like 9.00001, and we don't want that because you can't have 0.00001 of a person. It also has other uses, but the main thing to remember for now is we just want to remember that int takes off everything after the decimal place and it does not round. That's a common mistake that I see people make is they say, oh, int of 9.999999999, they'll assume it evaluates to 10 and it doesn't. So we just look before the decimal place. I can also change an int to a float. So if I do float of 8, you can see it's made into a float now because it says 8.0. Obviously not as interesting because when we make an int to a float, it's just going to add a 0.0 onto the end. But we can switch back and forth between these types, and Python allows for this. Another type that comes in very useful is the string type. So let's clear this. So string is a word used in computer programming that basically means a string of letters and numbers and symbols. It's basically a word, but more flexible. So an example of a string would be my name, Amy Fever. And you will notice that I put single quotes around this, and this is what tells Python that it's a string. I can actually also use double quotes, and it'll still read it as a string. You can see it changed it to single quotes, but single quotes or double quotes will be read as a string in Python. The only thing to be aware of is you don't want to be like Amy Fever and then switch, so you don't want to have single quotes mixed in with double quotes. It doesn't know what to do with that. It says unterminated string literal because it knows the string starts here, but it doesn't see the string ending. So we need to put the quotes around words, around strings. Text might be another good word for what a string is. Because if I just put something like Amy Fever, it's going to get confused. Because it's like, I don't know what these words are. It's like fever, is that supposed to be a command? Is that supposed to be the name of a variable? I don't know what to do. If I put Amy, it's like the name Amy is not defined. So it won't know what to do with these words if we don't put quotes around it to indicate that it's a string, because it's going to look and say, okay, is there a variable with this name, or is there a command with this name? And it's going to try to see if it can execute something like that. So I will use single quotes. Some people use double quotes. It does not actually matter, as we saw. It's just that the Python interpreter will always feed it back to you with single quotes. So I could say something like, I am Amy and I like penguins. I've enclosed the whole thing in single quotes, and you can see that, we can put any sort of characters. It doesn't just have to be letters and spaces. I can put punctuation here, and it's still going to support that. So a string could literally be star star, ampersand, ampersand, HG, 88, parenthesis, parenthesis. As long as I put it in quotes, Python is going to say, okay, I have a string that holds this information, even if it seems bogus. So it doesn't have to be words. It doesn't have to be a phrase. It can be any sequence of characters that you want to have stored for one reason or another. We could also use quotes around something like a number 8, and then it's read as a string. So if I do type of something like 8, obviously it tells me as an int. But if I did type and I put quotes around my number, it's going to say this is a string, because whenever we put quotes around any characters, even if it's a number, and as an external reader, we would just be like, oh, that's the number 8. Python is still going to read it as a string if there are quotes around it. So we can store strings in variables. So maybe I'll call something S1 and hello. So it's going to store hello in S1, S2, world. Then I can print these, so I can say print S1, and it's going to print hello. When you print it, you can see it loses the quotes because it's making it into a display for someone who's looking at the output of the program, and as human beings, we don't tend to think about things or about strings with quotes around them. But if we ask Python for just the value of S1, it'll put the quotes around it. So S1 is hello, S2 is world, and I can also print multiple strings. So I could say print S1, comma S2. And what it's going to do is it'll print S1, it's going to put a space in here, and then it'll print S2, which is world. So the Python print function supports multiple inputs, and it's just going to put it together into a single string, providing everything is already a string. I could also say print 8, and I think I used X earlier for 10, and I could print 8 comma X, and it'll print 8 and 10 without a space, or with a space, I mean. And I want to point out that the space in the print function is not what translates over to the space in here. So even if I didn't put a space between 8 and X, it's still going to print it with a space. So the commas will always give rise to being a space between the different things that are being printed. We can also provide our own text. Sometimes we might want to print something like the value of X is, and then we want to know the value stored in the variable X. So I could say the value of X is X, and it'll tell me the value of X is 10. You'll notice when I put this into the print, I had to surround it by single quotes again, so that it knows that this is a string, and it's not trying to look for, again, like commands or variables with the names the and value and so on. So even if I am telling it to print this statement directly, I still have to treat it like a string and put single quotes around it. There's a lot more we can say about strings, a lot more that we can do with strings, and I think that will deserve a whole extra video. But for now, it's just useful to be able to make use of these for, output and also taking basic input as a string. 2 other types I'm going to go over are list and bool. Let's do bool first. Say I say t equals true, and then I put the value t, and it prints true. So this is not a string because I've not put quotes around it. It's actually a word in Python that has a meaning and purpose, and the word true can be stored in Python and then used later. So if I say type of t, we can see it says class bool. So bool is a type in Python, and in any programming language really. Bool is a type that stores true or false. So we have t storing true, and let's make the variable f store false. So if I do, type f, it's going to tell me it's a bool, and if I print f, it's going to tell me the value is false. This is a weird concept if you're new to this. This is very useful because there are so many examples of how this can come into play. So say you go to a website and you click a button saying, "I'm not a robot," right? That button is either going to process a true saying, yes, they clicked the button saying they're not a robot. And then if it's processed a true, it will then, in the logic behind it, allow different actions to be taken. So often a true or a false are used to make decisions and decide different actions in a program. Another example would be if you had a program that was doing something like assigning grades to students, and you would say, well, did the student get above a 90%? If it's true that they got above a 90%, so another Boolean value of true or false, then you give them an A. If it's false, then you have to determine if they got a B, C, D, or F. So true or false are really important. They seem like a very strange concept if you don't know their purpose, but they're great in decision making, and they're great in controlling the logic of a program, telling you which action to take, telling your computer when to stop taking an action, and so on and so forth. As a quick way to show this point, let's go back to the example of assigning a student a grade. So maybe a student got a 91, so we're going to say grade is 91. And then I might say, okay, let's print if grade is bigger than or equal to 90, the cutoff for an A. And you can see if I say, is grade bigger than or equal to 90, it gives me a value of true. So we'll go over, all the comparison operators, greater than or equal to, so on and so forth. Greater than is an obvious operation. Greater than or equal, you can see the comparison happening here. We just put the two symbols in order. But again, right now, we just want to know the different variable types. So don't worry about knowing, the different comparison operators. We'll go over that when we talk more about some Boolean statements. For now, I'm just pointing out some of the basic variable types, and the point is knowing that bool exists, and bool is a type that stores true or false. And because that seems like a foreign concept, I want to just elucidate the fact that this is often used in things like decision making. So if grade is bigger than or equal to 90, the return or the result will be true, which means that we'll go ahead and do some action. Last, I'm going to talk about lists briefly. So a list is a way to store a collection of items. So possibly, we'll go back to the grades example. Maybe my quiz grades throughout the semester have been maybe out of 10 points, and I've gotten 8, 7, 9, 10, 10, 3, 0 because I missed a day, 10, 10. This is a list, and I did put spaces between the numbers. That's not necessary in terms of how Python will read it. I could have left out the spaces, but I put spaces between them. So this is a collection of 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers that are all now stored in this one variable. And this is really nice if we want to do something like group together a bunch of values and be able to just access them from one name, one variable. Lists also do have some nice usages because they're so common. There's extra functions that can be used on lists. But for now, again, we're just going over what the types of variables are. And a list is something that stores a collection of items in order. So I wouldn't print the list out later and have it switch the order. So if I have it print it, you can see it's just going to parrot back what I have. And if I do type of quiz grades, then it's going to tell me it's a list. Lists do not have to be used only for numbers. So I could have maybe names, and we have the names of a bunch of people. Names are strings, so we want to put them in quotes. So maybe these are people on my team. We have the names. Again, are stored in a list. We can tell it's a list because it has the square brackets at the beginning and the end. Sometimes you'll see things with a round bracket, like a parenthesis. That is a different type. So the square brackets in particular are needed for the list. And then I've listed a bunch of items, so a bunch of strings. So if I want to now print names, again, it's going to just parrot that list back. And if I do type names, it again tells me that we have a list. The last thing I'll mention for lists for now is that we can mix types in lists in Python. We cannot generally do that in most languages. So, I don't know, let me say a list. Again, I don't want to call something list because that word already means something, so I'm going to call it a list. And maybe my list has 5, 9.999, and cow. And while I'm at it, it has a list inside. Okay, so this is a list, and it contains 4 different types. We have an integer, we have a float, we have a string, and we have a list within the list. That is valid in Python. We can store any collection of objects. They don't all have to be the same type. And again, that's not necessarily valid in other languages. So I could print my list, or I could just say a list, and I get the list back. And again, even though the types are all mixed up, I could say type of a list, and it still tells me it's a list. So these are our 5 basic variable types in Python. They do need more exploring. There's a lot more to do with them, and that will be best done through different examples using these more than just one line of code like I've been doing here. But the 5 types are integers, which are whole numbers, things without a decimal. These can be positive, negative, just any whole numbers. Float, which is a numerical type as well, but that can support decimals. So 9.999 is a float. Even 5.0 is a float. Technically, 5 is an integer, but if it has a decimal like 5.0, then it's a float type. We have strings, which is just a sequence of characters. Often these are used for things like words or text, but it could just be a bogus sequence of characters. And then we usually wrap it with single quotes to tell our computer that it's a string, though it's valid to do double quotes around it instead of single quotes. We have Boolean type, which just stores a true or false value. And these are very essential for your computer program to make decisions what to do next. So if something's true, it might do one action. If something is false, it might do another action. And list, which is a way to store a collection of objects. So lists are ordered. They can store different types within them, pretty much only in Python. A lot of languages don't support different types in lists. And these are mutable. Mutable just means that we can change the contents of the list, change the size of the list, add things to it, remove things from it. And that is where we're going to leave this lesson for today.